All right, so we're going to look at piecewise functions again, but we're going to take it just one step further today. We're going to add in, did I just spell piecewise right? We're going to add in quadratics and values. So just up one tiny little notch from what we were talking about. So we know that piecewise functions generally look like this. They have this fancy brace, and that tells us a little bit, and that tells us the multiple functions that are going to work together to create one function. So let's say we have something like this. And I'm going to tell you that f of x equals x squared when x is less than 3. And I'm going to tell you that f of x equals negative x plus 5 when x is greater than or equal to 3. So the only difference here is that we're throwing in a quadratic function, and we're going to do the exact same process. It's just going to have a parabola in it, and that's totally fine. So if we do this, I'm going to just draw a rough graph. We know that x squared is just a parabola, and it looks something like this, right? And then we also know that negative x minus 5 is linear. It's got a negative slope, and it crosses the y-axis at 5. So it's going to look something like, let's see, it's going to come up here at 5, and it's going to be headed downhill like this. All right? So the next piece is I'm going to come over, and I'm going to see where that cutoff was. And my cutoff was at 3. So I'm going to take my eraser, and I'm going to go erase the parts that aren't where they should be. So if my cutoff line, I'm going to draw my cutoff in yellow, let's say, is right about here, then I'm going to go and erase the parts that don't match. So my parabola doesn't exist past there, so I'm going to erase that. And my linear line doesn't exist on the left side, so I'm going to erase that as well. And then remember, your yellow line isn't actually there either. So what you kind of end up with is something that looks like this. Actually, this is probably higher. And your parabola should have an open circle, and your linear line has a closed one because that's where it's equal. So a piecewise function with quadratic function in it looks the exact same. It just has a parabola thrown in. Okay? Let's try one more. And this time, let's use an actual graph so we can make sure we get this as accurate as possible. Okay, so let's try, and I want you to notice I'm not using y equals. I'm using f of x because that's definitely a more proper notation. So we're going to say negative x minus or plus 2. Our next function is x, and then our next function is x minus 1 squared. All right, negative x plus 2 is happening when x is less than negative 1. X is occurring between negative 1 and 1. And x minus 1 squared is happening when x is greater than or equal to 1. Oh, I'm sorry, I missed a, or equal to 1. Okay, so I'm going to go over here, and I'm going to go put out my invisible barriers just because it makes my life a little easier to see. So I'm going to, oh my, what did I do? I'm going to put out orange. I've got a line at negative 1 is going to be one of my cutoff points, and then positive 1. So you can really do that either way. You can draw your lines first and then your graph, or you can draw your graph and then your lines. It's really up to you. Okay, so negative x plus 2. So that's a negative slope. It's crossing at 2, and it's going down 1, up 1. So I'm going to start that here, and it should look like this, right? Okay, there's that piece. This is my green piece. And then f of x equals x. Well, that's a slope of 1 that crosses at 0. And that's so it's going to look like this right there. And then negative, or x minus 1 squared. So this is going to be a parabola. Remember what we know about this. This just means that it's shifted to the right one place. Remember, because we reversed that since it's inside. So this is going to be right here, and it's going to be just a parabola that does this. Okay? So now let's make sure we've got our open and closed circles the right way. So let's come back and look at this. This is occurring when x is greater than or equal to 1. So I'm going to come over here and I'm going to make sure that at 1 I have a closed circle. On this, x occurs between -1 and 1. So it's equal to, at -1, an open circle at 1. So I'm going to go make real sure that I put an open circle and a closed circle on my blue line. This function is not equal to -1, so I'm going to make sure I've got an open circle there. Okay, now here's what I've got. This is my final graph. I'm going to come erase my orange lines because they're not really there. And if you don't want to draw orange lines, then you don't have to. But they can be helpful at first until you get a little more comfortable with the whole process. So the next level of this is we're going to start looking for values. Now, when we talk about values, if I want to know what's happening when x equals 5, let's say I want to know what's happening when x equals 5. The way I ask that is that I'm going to say f of 5, right? Because remember, my function was f of x. Well, now I'm telling you that x is 5. So I'm going to replace the x with a 5. So f of 5. That's how I say that. F of 5. That's how we pronounce that. And that means I'm going to replace all of my x's with 5. However, because this is piecewise, which of these three functions am I going to use for that? Well, 5 is not less than -1. 5 does not fall between -1 and 1, but 5 does fall greater than 1. So I'm going to plug my 5 into this function because it's greater than 1. And you can see graphically, like if I want to know what's happening at 5, I come over here. Well, that's in the red section. So duh, I'm going to use that function. So I'm going to say 5 minus 1 squared. Because remember, I'm replacing my x with the 5, right? So 5 minus 1 is 4. 4 squared is 16. Wow, I should really work on my graphing. Okay. Let's look at one more of those. What if I want to know what's happening when at f of -2? So if you're being asked what f of -2 is, you need to come determine which of these functions happens at -2. Well, if we look real closely, is -2 less than -1? Yes, it is. Okay, so we're going to use that function. So we're going to say -2 plus 2. Remember, you're putting your negative in for x, and that negative right here is really a -1. So now you've got -2 is 2 plus 2, which is 4. So f of -2 is 4. Do you see how this works? Are you getting it? Okay, sometimes they're a little trickier though. What if I ask you, what is f of -1? Okay. -1 is showing up in two spots, but we're going to use this function because it says -1 is equal to x. Here, it's not equal to, so we have to be really careful which one we're going to use. So we're going to use this function. f of x equals x. So if we plug that in, we just get, well, we get -1. And that's it. Not too bad when we're looking at values. This wet notation of asking for specific values is not specific to piecewise functions. We can use that with any function. So despite the function, we can always take whatever's been given here for x and replace it, even if it's just one plain old simple function. Okay, that's all there is to it. I hope you understood it. Let me know if you have any questions.